Lastly, I want to look at matrix multiplication. Multiplying matrices together is a bit more complicated than the addition and subtraction that we've already looked at. We have some conditions for multiplying matrices together. We need to look at the orders of the matrices. The number of columns in the first matrix must equal the number of rows in the second matrix. Basically, if we have an m by n matrix, then the next matrix, the first part of the order needs to be an n. We can have an n by p matrix. If these two n's match up, if they're the same value, we can multiply the matrices together. And what we end up with will be an m by p matrix. Let's try some examples. Example 3, I want you to multiply the following matrices together. If you want to, just follow along for part A and then try part B on your own. Right, for part A, we see that this is a 2 by 2 matrix multiplied by 2 by 2 matrix, which means we can do the multiplication and that we should end up with another 2 by 2 matrix. The easiest way to go about matrix multiplication is to kind of lay out your matrices. I'm going to write my first matrix down to the left and the second matrix above. This orientation is very important. Okay, to figure out the first element here, what I want to do is use this row and this column. They both feed into this first element. I do 1 times 2, which is 2, plus 0 times negative 1, which is 0. That becomes my first element. Okay, to solve for the second element, I'm still in the first row, but now I'm in the second column. So what I do is 1 times negative 3, which is negative 3. Let's give us a little bit more room here. Plus 0 times 8, which is 0. That gives me the second element. Right, to solve for the third element down here, I want to now use the second row and the first column because both of these feed into that second element. Do 4 times 2, which is 8, plus 5 times negative 1, which is negative 5. Lastly, I'll take the second row and the second column because both of those feed into my last element. 4 times negative 3, which is negative 12, and 5 times 8, which is 40. What I want to do now is to simplify my solution matrix. Two plus 0 is 2, negative 3 plus 0 is negative 3, 8 minus 5 is 3, and negative 12 plus 40 is a positive 28. That is my final matrix. So it's really important that you get this set up correctly. You need to put the first matrix down and to the left and the second matrix up above. The order matters. Unlike what you saw in regular algebra, matrices do not have a commutative property of multiplication. The order matters. Taking 1, 0, 4, 5 multiplied by 2, negative 3, negative 1, 8 is different than if you were to switch their orders. So again and again and again, order matters for matrix multiplication. You cannot just switch them. Let's look at problem B.